Good morning, everybody. We're going to go ahead and start our next lesson, which deals with exponential functions. So we're going to define what an exponential function is. We'll take a look at how we graph exponential functions. We'll take a look at some properties of exponential functions. We'll do some basic solving of exponential equations in this lesson, and then we'll also do an application of exponential functions being compound interest. Okay, but before we get into any of that stuff, we're going to review really quickly our laws of exponents. So we did some work with this way back at the very start of the school year. So we're just going to refresh right here. So our laws of exponents, we are going to let A, B, S, and T be real numbers with A greater than 0 and B greater than 0. Okay, and there are 7 laws that we're going to look at. So law number 1 says if we take a to the s power times a raised to the t power, so if we multiply 2 exponents that share the same base, we can rewrite that as a raised to the s plus t power. So we can combine into a single exponent by adding the powers. For law number 2, if we have a power raised to a power, so if we have a to the s power raised to the t power, if we have a power raised to a power, there is where we multiply exponents. So that is equivalent to a raised to the s times t power. For law number 3, if we have a times b raised to the s power, so if we have a product raised to a power, we can go ahead and apply that exponent to each factor. So that's going to be a raised to the s power times b raised to the s power. Number 4, if we have a quotient raised to a power, we're going to take, again, each factor and raise it to the s power. So that is a to the s power divided by b to the s power. For law number 5, if we have a raised to the 0 power, a raised to the 0 power is going to be equal to 1. For property 6, if we have a raised to the negative s power, you can write that one of two ways. You can write it as 1 over a to the s power, or you can take the reciprocal of the base 1 over a and raise that result to the s power, which is like saying 1 to the s power over a to the s power, and 1 to the s power is just 1. So again, that's equivalent to 1 over a raised to the s power. And then property 7, law number 7 says if we have a raised to the s divided by t power, we can rewrite that as, so when we have a rational exponent, the denominator becomes the root for our radical. So that's like the teeth root of a, and then our numerator is just the power for a. So a raised to the s divided by t power is equivalent to the teeth root of a raised to the s power. Okay, so those are some things that we're going to need to know as we move through this lesson here. Okay, so let's get into defining the exponential function next. So an exponential function is defined as a function of the form f of x equal to a raised to the x power, where a is a positive real number. Okay, so where a is greater than 0 and a cannot be equal to 1. And the domain of any exponential function is the set of x such that x is a real number. Okay, so we can input any number we want into an exponential function and it give us a valid output. Okay, so what we're going to do next is we're going to talk really quickly about graphing exponential functions, and then we're going to use the graphs that we come up with for problems 1 and 2 to generalize some properties of exponential functions. Okay, so I'm going to assume that we've never graphed exponential functions before. If you have, then this should be review for you, but if not, we'll take it slow with this here. Okay, so for number 1, we have the function f of x equal to 3 raised to the x power. Now, I'm assuming that we don't know what the graph of this function here looks like. So what I'm going to do for this graph here for number 1 and number 2 is we're going to make an XY table for both. And then I'm going to give you kind of a process that you're going to use later on that's a little bit faster for graphing exponential functions. Okay, so we're going to make an XY table. We're going to pick a few different inputs for X and see what the corresponding outputs are for Y. So we're going to go ahead and pick the input values -2, -1, 0, 1, and 2. And when we plug these X values into our function, the corresponding Y values, so when I plug in -2, 3 to the -2 power is 1/9. 3 to the -1 power is 1/3. 3 to the 0 power is 1. 3 to the first power is 3. And 3 squared is 9. Okay, so that gives us 5 points on the graph of our function. So let's go ahead and plot those 5 points. So we'll make each dash mark in both the X and Y direction correspond to 1 unit. Okay, so we can take the ordered pair -2, 1/9, plot that point first, which is there. -1, 1/3, which is about here. 0, 1, 1, 3, and then 2, 9. Okay, so we're going to connect those 5 points with a curve looking like so. Okay, so that's the graph of 3 raised to the x power, and we're going to refer to that graph looking at trying to determine some properties of functions of that type. Okay, now we can do the same thing for number 2, where we have the function